All right, so AB has an endpoint and was dilated scale factor from center to 0. Which statement describes the pre-image? Okay. So scale factor is multiplying by a half. You said you got this one wrong. Is that right?
No, I actually haven't done
Or
this
you've not answered it yet. That's what I'm trying to.
Yeah, I haven't answered this
No,
question
don't
yet.
you? Okay, got it. So half
Yeah.
is the key here. And then the question is, well, where is the new new point here? Sorry about that. Always have the dingers on during your lesson. Okay. So 2, 0 is there. And it has endpoints. The original is endpoints there. Where is the pre-image? Pre-image. So is it located at A, which is -2, 0? Okay. So I'm just drawing the points here, and that's where I'm sort of stumbling on the answer here. The original graph, it's almost easier if we go from the answer. So imagine graphing -2, 0 and 2, 0 right there. There's some sort of a line segment right there. And then we're choosing 2, 0 as the center, and we're taking half from it. So we're going to cut each of these points in half. Well, the one that's on it doesn't change, but the one that's over here on it gets pulled in to right there, and that's your new line segment.
Um, let's see.
Does that sound okay? Or more explanation needed?
A little bit more information. A little bit.
I cannot hear you if you're speaking.
I was just saying that a little more information maybe needed to clarify a bit.
Okay.
Um,
Well, try to do this differently. When you stretch something from wherever the center is, and you stretch or pull it, it changes. It stays along that center. So like half of that and then half of that, it's still half. It doesn't like pull in on both sides. It just pulls in from one side. Right. So in this problem, the two possibilities, because it's a scale factor of a half, it's either A or C because of that. And it's like, well, where were the original points? So let's just go with the other one. Let's go with the one that's not correct. -1 and 1. If that's the original, and your center is over here at 2, 0 now. That's your center.
wait, if it was by a scale factor of half, and it's giving you like the points that are the image of the pre-image, wouldn't that be twice the length of or
Well, okay, I understand your question, and I'm going to reread it as well. I'm assuming that the original was dilated by a scale factor of 1/2.
uh
It says it was dilated.
yeah, so like I
To
guess let's
get
get
it?
the question. Yeah, because I think what I'm trying to say is that it gives you the points like after it was dilated by a scale factor of 2 from the center
Yes,
of 2,
that's what
0.
I'm taking it. These are the points after the scale factor dilation.
Got it.
Okay. So what I'm trying to show you and is that on the one on the right here, there's like an arrow to the endpoint and then to the other endpoint. And you're cutting each of those in half. So when you cut them in half, you get like half and then a half. So you get kind of these awkward points, which aren't really on the grid. They don't have to be on the grid, but these are definitely not on the grid. So the reason the one on the left works is because when you've got a zero length vector to because the center is on one of the points. That's the center. It's on one of the points. So no matter how you dilate it, it's still right there. But the other one, you can think of it as an arrow to that point. Well, if you cut it in half, it has to be this in between arrow.
Got it. Got it. All right. I did this question already, but of course I haven't submitted all of this stuff yet, but wanted to go over
Sure.
see if I got it correct or not. Or
All right, there it is. A triangle EFG is dilated by a scale factor of 2, centered at 0, 2. That's important, is there's the center. All right, so what you're looking, like if you were asked to just make the scale factor, you actually almost need to redraw kind of like the connection points to that, because that's what's changing. Those lengths there, they're all being pushed out a factor of 2.
got it.
All right.
Yeah.
Now, so I mean, we can go through a few of these things to see which ones are wrong. That's probably one way to do it. So is EG going to be congruent to E prime G prime? So like, no, like what it's going to be, not exaggerated, but it's going to be more like, yeah, I can't, now I don't have room to show this, but it's going to be a much bigger triangle. Maybe try to show this here. How to do this. So the new triangle will be roughly, 'cause that's about 1, be right about there. And then that's 2 and 5. So it's gonna be up like there. And that one I can't really get on the screen, but like that's the triangle. It's gonna look something like that.
Got it.
So it's much bigger. And so there's no way that they're congruent. Now, will the slopes be the same? If you do a certain center, yes, but not in this case. You can just sort of eyeball it that F, which is this one here, is not going to be the same as E H prime, although we should check that. But no, I mean, that's going straight up and down. I'm trying to avoid creating the new points, but I almost feel like we have to. EF, H prime F will overlap. So that one right there will overlap HF. Doesn't look like it. So EH, and EH prime best both pass through the center of dilation. So sorry, I am So off today. I apologize. I'm using the wrong center. That is not, sorry, I need to restart this problem.
No problem.
Okay, so the center here, let me actually do it correctly here. Oh boy. There's the center, 0, 2. Okay. So what it's going to do is you create like a all the points of interest, these are all going to get pushed out too. So you can think roughly there, roughly there, roughly there, and then this one's going way up here. And so the new triangle is much, much larger. And then to answer your question, yes, they both pass through the center, the same center of dilation there.
Got it. All right, let me. All right. So I got I hadn't submitted it, and there was a couple ones I got wrong that I did by myself, but yeah, let's go over them. So the first one is number 3. Let me put that in the chat.
Okay, there it is. All right. All right, so let me grab this. All right, so Jason considered two similar televisions at a local electronics store. Generic version was based on the brand name. It was 3/4 the size of the brand name. If the generic television was set as 12 inches by 24 inches, what are the dimensions of the brand name television? Okay. I think this is just a simple matter of going the wrong direction. Based on the brand name and with 3/4 the brand name. Okay. So I think the simple issue here is you thought that 12 and you take 3/4 of 12 by 24, but it's all in the wording here. The generic version was based on the brand name and was 3/4 the brand names. The generic equals 3/4 of the brand, but notice that they're giving you the generic here.
Um,
All right, so to undo it, go the other way. The brand name is 4/3 of the generic.
got it.
Okay, so 4/3 of 12 by 24. This is one of the rare times when they actually do a good job with the multiple choice and they actually put in, hey, both possibilities so that you got to really know which way to go. You know, it's 16 by 32.
Got it. All right, so another one I got wrong was right here. 1 second. Good. Try that now. I think it was number 7 there. All right, it's in the chat now.
So
Yes, sir.
triangle XYZ is translated by the rule x plus 1, y minus 1, then by a scale factor of 4 centered at the origin. Which statement describes the properties of the triangles XYZ and XY or X double prime, Y double prime, so on? Okay. So first thing is when you move this triangle, like whatever triangle you choose, when you move it right one and then down one, it's the same triangle in size.
Yeah.
Is that okay?
Yeah.
Um, so they're congruent. They're congruent after the translation. So but what happens when you use the scale factor? So the scale factor causes it, especially when it's at the origin, is it just gets bigger. It gets, we don't know where it is. So let's just say the origin was right there, just for convenience, like it just gets bigger. This is not to scale, but you can see that they are proportional.
Yeah.
So the you talked about rigid, I think rigid motions or something earlier in the course.
Yeah.
Um, translations, a congruence is maintained. And then whenever you do a dilation, you have proportionality
Got it. Got it.
always.
Got it. Alright, so, let's make- So here, I think we should be able to do this here. So related to the honors extension that we did, I think we did yesterday, related to that, apparently she didn't want to, it wasn't based off of the other two that I thought. So, so instead for it, she wants us to like find something and then create a construction based off of it. And then see if there's any transformations like reflections, translations, or rotations present in that construction, and then use complete sentence to describe the
Okay, well, let's give it a
transformations.
shot.
All right, so first we need to construct construction.
Whenever you can, if you could drop a picture in the chat of
Yeah,
what you're
yeah.
working on.
Just reading the instructions. Instruction. Just read that. All right. Yeah, let me just quickly draw.
Yeah, if it's easier, I can maybe go back in my notes and look for something. What would be best?
Okay, All right. All right. Right. There we go. All right. I got the instruction. So here. All right. Picture of that.
Okay, this didn't come through. Well, we'll see if it's the iPhone extension. They don't always. Let's see if it works. Okay. I mean, I'm seeing a picture of an iPhone. What is it that we're supposed to do with this? Maybe we're not in sync here, but let me just snip in what I got of.
See this need. Let me put the directions as well in the chat right here. So I guess we're like supposed to split it into like different, to go shapes like almost like a triangle, then do it because yeah, it's a little bit creative.
Examine your selected object and the construction you made. So you're supposed to create something.
Yeah, based off like an object.
Okay. I mean, I would keep it really simple. I wouldn't have these rounded edges if you're asking, but we can do anything you want. But this is, I mean, I would maybe just make it simpler. Just say, this is my,
Yeah, kind of like take out the rounded part, just make
yeah,
it like a
this
rectangle.
is my phone. And you might even be more specific and put, okay, here's the origin. And then whatever I got here, 1, 2, 3, 4, 5, 6, 6, 0. And that's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so this is 6, 11. 0, 11. You definitely want to label those points.
Got it. Okay.
All right. Now, what kind of transformations do you want to do here? And we can do, how many do you need to do, I guess, is maybe the better question.
Um,
And then another thing I'll just add is like, there's no reason to make it this large. That just creates a lot of challenges. Like you can do the same set of things with something that's, 2 by 3 also. Just say
got
that.
it.
And then, if you're asking me, but
Yeah, so it doesn't really tell you how many reflections, rotations, or but usually like some of the other assignments when I submitted it, I did like maybe like 2 or 3, and then
we should just do one of each. We should do one translation, one reflection, and one rotation. How about that?
yeah, yeah, we can do that. Yeah.
Okay. So again, like if you're asking me, I'm going to make a table of values here, X, Y, and we have 0, 0. I'm just going to label the 4 corners here, 0, 0, 2, 0, 0, 3, and then 2, 3. And so the first transformation is a translation. And do you want to move this thing up, down? We should move it either right or up, I guess I will say that.
Like I think we can probably do like, I don't know, like 2 to the right and then 1 up,
Okay,
something like
so
that.
and we could do 2. We could do 2 if we want, but we'll go right 1 and maybe up 1. Okay.
Yes.
All right, so that that's gonna affect both the X values and the Y values. You're adding one to each. Okay, so that takes care of your um. My question to you is, do you need to graph each of these, or do you want to graph it at the end?
Um, but I'm not really sure what the picture asking though, because it says, are there any transformations, reflections, or rotations?
Yeah,
So,
I don't know.
yeah,
This is all you.
yeah, because it doesn't say anything else about it. It's the only directions it gives. So I guess you're supposed to do the reflections, rotations, and
Okay,
uh,
well, let's just take this and now we'll do a reflection over the uh, y axis. Okay, so all that does is it negates the X value.
yeah.
All right, and then one more here. Let's do a rotation. Um, so currently this object is in the second quadrant. Um, it's over here to the left. So we should do, rotation 90 degrees clockwise, or we should go 90 degrees counterclockwise. Do you have a preference?
Not really.
Okay. So let me pull up the transformation guide here. So we've got it, because I don't remember any of these without doing it. Okay. So 90 degrees counterclockwise. We'll do that one first. So we'll choose the one on the left here. All right. And grab this table again. All right, so the new XYs become you take the X value and all these X values move it into the Y column. And then the Y value is negated. So it's -1, -1, -4, -4. Okay.
Mhm.
All right. So probably want to graph the final one. So the original one, try to do it here. The original one was like here in red. Okay, and the new one, it's not terrible. It's -1, -1, -1, -3. Yeah, -4, -1. So and so we could come up with a little story here. Maybe that's part of it, which is uh imagine a phone represented by a rectangle as shown in red. First is slid to the right and up 1 unit, then is flipped, which means reflected over the y-axis. Like, I mean, that's like flipping your phone on from front to back. then rotated 90 degrees counterclockwise from the origin.
Yeah, that would make the reflection and also rotation, because you're reflecting over that y-axis and rotating 90 degrees clockwise. And then we could maybe, I don't know, well, actually, yeah, we've rotated it, reflected it. So wait, can you scroll up for a second?
Sure. How far?
Back to the so the original points were zeros, a little bit more down, just not quite. So the
These
original
right here.
point would be, yeah, so minus 0, 0, 0, 2. Yeah, but, 0, 2, 2, 0, 3. Got it. Got it. Got it. So we're doing a translation to the right one, up one. Okay. It's right here. And X. Mhm. 2, 3.
We're coming up on couple minutes here, so please, get down
Right.
or let me know if you've got some questions here.
Reflected across the Y. So reflecting across the Y vector. So then we're rotating it. So are you reflecting across the x-axis then?
Y-axis,
The
y-axis.
y-axis, so then all right, got it. Reflecting across the y-axis. Translation to reflection. And cross. third, we're rotating it 190 degrees counterclockwise. Got it. Rotating. Wow. Yes. Counterclockwise, counterclockwise, counterclockwise. Working it open. Oh yeah, that did. Probably line up. Yeah.
Is there anything else you need to get down? I mean, this will be in the notes here in the next few minutes.
No.
Okay.
Yeah,
So if you do need a lesson over the weekend, let me know. We can figure out something. Right now I don't have any times just because a lot of students aren't scheduling, but if you don't need anything over the weekend, we'll get back on schedule next Monday